Hi everyone. I wish all of you happy Republic Day. I hope we all will have a great new year ahead and I wish for your bright future and with the same spirit let's solve the further maths problems which were asked in GATE. Okay, so I'm taking a problem of GATE 2023 and this carries 1 marks. This problem was belonged to again calculus and it is a problem of maxima and minima. Let's solve this. Let's solve this. Fx equal to x cube plus 15x square, x cube plus 15 x square minus 33x minus 36. Now, what they are asking, if you can see the option, very important thing is or are correct. Means there may be more than one answer correct, maybe one correct or maybe more than one correct. So these kind of questions has been added in GATE. These we say multiple select answer questions, MSQs. So multiple possible answers are there. So that's why he is writing is or are. So first word I literally want to highlight here is, please don't forget this. Many times we feel it is an MCQ type question, but it's not. It is an MSQ type question. Okay, so more than one answer may be correct. Now they are asking there is some local maxima and local minima. You can see from the option they're talking about local maxima and local minima. If you have to find local maxima and local minima, first you differentiate it. Okay, it's a polynomial of order 3. So let's differentiate it. F dash x is equal to 3x square plus 15 into 2x. So directly I can write it as 30x minus 33 minus 33. So whenever you are solving a problem from maxima and minima, you need to find the critical points or stationary points. Critical points or stationary points are those where your first derivative is 0. It means slope of tangent is 0 there. Tangent is parallel to x-axis or slope is not defined at those points. But you can see that this is a polynomial and slope is defined at every point. Slope is defined at every point. So this will looks like if f dash x equal to 0 will be the critical points. So you can take 3 common. This will be x square plus 10x minus 11 equal to 0. Okay, this implies 3. One root you can say 1, it is there, right? Or you can write 10x as 11x plus x. Okay, and one root I am able to see that it is 1. So 11 minus 11 is 0. So another root will be, you can multiply by x because x square term is there, and minus 11, so plus 11 is equal to, or whatever way you want you can use to find root. I generally, if I see any one root is available, for example 1 is visible to me here, so I have written x minus 1. Now you have to create the term x square. So what you need to multiply x, so I multiplied by x, and then you have a constant term. You can see a constant term here, so minus 11. So I should multiply minus 1 with plus 11, then only I'll get minus 11. Okay, that is one way to find. Otherwise what you can do, this 10x you can write as 11x minus x, 11x minus x, then again you can find the same thing. So roots are x equal to 1 and x equal to minus 1. So these are the critical points which can be either corresponding to maxima or minima. So now if you want to find which is maxima, which is minima, then you need to apply test. I'm applying here first derivative test. So in first derivative test, you can see you have to plot the line and just plot these points minus 11 and 1. So you can judge maxima or minima with help of sign of the differentiation. If it is maxima, you can see a maxima looks like this. So in left side of maxima, if you can see the slope, it is positive. So f dash is positive, and the right side it is negative. Similarly, for minima, if you apply this test, at left side f dash is, because theta is in second quadrant, so f dash is negative and this theta is positive, so f dash is positive. This is nothing but first derivative test. I have written for you just for the recalling purpose. Okay, so these videos are actually made for your revision purpose only, right? So that you can easily understand the concept. That's why I'm taking time to solve it, right? So one by one, I'm telling the step how to solve. In exam, you can quickly solve it. You can quickly solve it. Okay. Now we need to find the nature of this function, whether it is positive or negative. Okay. So when I keep a value in f dash x, this is f dash x, right? F dash x, I can write as 3 times x minus 1 x plus 11, x minus 1 and x plus 11. So when I'm putting value which is more than 1, let's say 2, if you keep a value which is more than 1, let's say 2, so this will be positive, 2 minus 1 positive, 2 plus 11 positive, so product will be positive. So it means whenever you are putting a value which is greater than 1, you will getting a positive slope. Now, in between minus 11 and 1, choose a point. Always choose a point. Let's say 0. I'll take one point 0. X minus 1, if you put 0, you are getting negative sign. Because I am only taking care of the sign. I just want to find what is sign of the derivative. So, it is negative. And this will be positive. And negative into positive will be negative. Similarly, I can choose a point here, minus 12. So, minus 12 minus 1 will give me negative sign. Minus 12 plus 11 will give you negative sign. So negative and negative is positive. This is positive. So when slope changes sign from positive to negative, so it is maxima. So this is local maxima. And when slope changes sign from negative to positive, so looks something like this. It is local minima. Local minima. So this function have actually both local maxima as well as local minima. Now you can read the options. Fx does not have a local maximum. Wrong. Fx has a local maximum. Yes. And we even find at what value it is. It is at x equal to minus 11. Fx doesn't have a local minimum. Wrong. Fx has a local minimum. Yes. So that's why they already told you that there may be more than one answer correct is or are. So what are the answers? B comma D. So please take care in the exam that you are reading the problem carefully and don't skip both the answers. Okay, if you see that is MCQ and suppose you got a maxima, you are just taking it and go away. It's not like that. Be careful. Many students lose marks in exam because of these small mistakes. Okay. So I hope this video is useful for you. Thank you very much.